Well, welcome to the Western Bird Banding Association's webinars. We've had some great talks this year, and this evening we'll have some great ones as well. I'm Danielle Kashubi with the Institute for Bird Populations, and I'm also the president of WEBA. I've been really enjoying all the talks we've been seeing, so I'm glad you've been able to join us. And we're going to give the floor to Geoff. Geoff's interest in birds developed as a teenager when he was an active volunteer starting in 1961, and then later as the chairman of the Long Point Bird Observatory. He earned his MSc and PhD from the University of Toronto for his studies of foraging strategies of diet of swallows. He retired in 2012 after 36 years with the Canadian Wildlife Service, including studies of peregrine falcons and burrowing owls, and he's chairing their national recovery teams. Among other things, he's tracked the results of the Edmonton Christmas bird count for 40 years and is now chair of the Beaverhill Bird Observatory. He co-authored the new the book Wildlife of the North in August 2023. And his latest research project is to track northern saw-whet owls from Beaverhill Bird Observatory to around North America using the MODIS wildlife tracking system. But today he's going to talk to us about those cute little least flycatchers. So, Geoff, I'm going to give you the floor. Thank you for being here.
Thank you, Danny, and thanks everyone for attending. I didn't get to ask, but maybe at the end, Jonathan could tell me if you catch any least flycatchers. And as you'll see, they have a differential migration. I'd be interested in if you catch them, is there a differential migration? But we'll get to that after I've told you about them. So I guess the thing I encourage Jonathan to keep going. We'll come back in 2060 for your talk about long-term trends, like I'm going to do from the Beaverhill Bird Observatory in Alberta. And now I just have to get this. Oh, there we go. So as a bit of background, I won't belabor this, but probably all of you know there's a publication a few years ago pointing out that we've lost about 1/3 of North America's birds. Roughly 2.9 billion birds have disappeared in the last 15 years. They don't just disappear, of course, they've died and not being able to reproduce. And amongst those, the worst declines were aerial insectivores, the right-hand column in blue. I depicted a swallow, but I should have changed that for a flycatcher for this talk. And you can see the trend here in the graph. The bottom line is the aerial insectivores that declined 59% over that 50-year period. So less than half of them are left. So 53% is the decline for least flycatchers between 1970 and 2014. Okay, and my down arrow is going to fight me. There we go. Oh. So many of you are probably familiar with the least flycatchers. Apologies to those of you in California, which aren't likely to see them unless you hit that little pocket in the northeast corner of your state. But they're widespread across Canada and portions of the northern US. Very common in deciduous forests. It's been known for some years that the adults migrate earlier than the young, but I'm going to show you some new insights there. When they breed, the current thinking is they're clustered. Whether it's actually a lek or not still is up in question, and I'm not going to be able to give you any insights there, but they're definitely an aerial insectivore that have declined elsewhere. Here's where the Beaverhill Bird Observatory is, and now I'm fighting. Okay, and so in central Alberta, this map shows the migration monitoring network that's coordinated by Birds Canada to monitor migrants spring and fall as they move into the boreal forest and the Arctic, and then back south into the US, Central and South America. Oh, and there we are, located 80 kilometers east of Edmonton on the south shore of Beaverhill Lake. And our pride and joy is our new research and education center with an 80-foot tower with a MODIS antennae and a MODIS station inside, which I'm not going to talk about today, but I did talk about in the fall. So I think it's on the WEBA website, talk about saw-whet owls. So least flycatchers are our most frequently banded bird at the Bird Observatory. I don't have an analysis here of the maps monitoring avian productivity. Some are banding, but it's one of the most, we catch as many or more than any other map site in North America, but that analysis will have to come later. So you can see the relative numbers here, over 11,000 as of 2021, and we banded a few more since then. And in fact, as many or more than other stations in the Canadian migration monitoring system. Bit of background. So in 1995, the Bird Observatory was established in 94, and you can see to the right of our buildings there is open grassland and willow meadow. And fast forwarding to this picture is 2013, you can see where our building is inside the red circle, and the star is the same point. The lake disappeared in the early 2000s and hasn't come back. That allowed the aspen to expand into that grassland and willow stand. And so what we have now is an aspen stand surrounding the bird observatory with some older balsam forest. So we've had significant vegetation change, and that has benefited the Lee's flycatchers. So you can see that is our Modus tower sticking out of the forest where our station is. We're no longer at the edge of a grassland and willow stand. And the area to the right of the circle is virtually all aspen forest. And then to the left and off the picture is balsam forest. And our breeding bird census covers roughly 20 hectares on both sides of the bird observatory. So what we've done is conducted a breeding bird census. This is a system where you record singing males at least 6 times during the breeding season. The ideal is to record simultaneously singing males, so you know there's a territorial boundary between them. You then create a map for each species and delineate territories. So in the year that we're just in the process of publishing, 2022, we found 99 least flycatcher territories in 1/4 of a square mile, or roughly 400 territories in a square kilometer, which is an amazing density, which allowed us to undertake a breeding study with a volunteer. So this is our aspen forest, young trees, as you can see. In June, it's not only are you listening to Jabix, but it looks like Halloween with all the cobwebs up. And this is likely a reflection of the huge insect abundance that we have. Unfortunately, some of those insects are mosquitoes, but there's lots of other insects that flycatchers and other aerial insectivores catch. So we studied the nesting habits of the least flycatchers. The young lady on the right is Myrthe van Bremt. She came as a volunteer from Belgium and did an amazing study for us as a volunteer in the afternoons while helping with all the morning banding. And then in November, she wrote up an article, November 2022, and it will appear in the March issue of Wilson's Journal of Ornithology. So the technique was fairly simple: to find nests, check their content with a pole camera attached to a smartphone, which is what Myrthe is doing right now, and then do a habitat assessment. So these are the kind of pictures that one can get using a pole camera like this. It was quite slick. We don't have to put up a ladder against these rather slim trees. And as you can see, the nest success was very high. 79% of the nests that had at least one egg fledged young. So very high nest success. Most of them were in trembling aspen, as I mentioned, and the mean clutch size was 3.9. So we had very few clutches of 5, but virtually all clutches were 4, very few 3s, and very high productivity, as I mentioned. Oh, and all of the habitat variables that Myrthe toiled over showed no difference other than a preference for aspen versus balsam trees. So this was actually the highest breeding density that's been published to date. You can see the other numbers there of 4 territories per hectare, or 400 per square kilometer, is double the density that's being recorded virtually everywhere else. I also might mention that our tree swallows that are in the grassland to the north have the highest levels of productivity of any tree swallows in North America. So the Beaverhill Natural Area, with its abundant insects, is a very prolific area for aerial insectivores. Our clutch size is roughly comparable to other studies, as you can see, but extremely high nest success, much higher than what's being published elsewhere. I mentioned that. High food availability. We don't have direct measures. We have started a one insect trap, but we don't have the results to share yet. So it's definitely a good breeding area for leaf flycatchers. We could obviously do more research on why. And in terms of the context of endangered species, leaf flycatchers are not listed, although they've declined over 50%, as I've said. But if it came to the time where they were endangered and critical habitat needs to be defined, then we're establishing a baseline for what critical habitat could be for the species. And remember how temporary this forest was. It appeared in less than 30 years, and in 30 years from now, it'd probably be a mature forest with much lower densities of leaf flycatchers. So that critical habitat may not be a static concept when it comes to this species. So the article that will be published in March argues that we need to do more studies like this, and obviously more detail, to define parameters that will define critical habitat while species are common, rather than doing it when they're rare, which is what I spent a lot of my career doing, establishing peregrine falcons back in Canada, and then trying to find out what was happening with burrowing owls across Canada, the parts of the US and Mexico. So I think this is just a repeat. So we'll go on. So we'll go on to the next topic, which we have just submitted to Wilson's Journal of Ornithology. And as Jonathan mentioned, some birds have differential migration. In the case of the leaf flycatcher, the adults migrate before the juveniles. And this was first documented at Long Point by David Hussell, a publication in 1981. And you can see there's a 30-day difference in the timing of these adults versus juveniles. The average is the mean, so a little bit of overlap, but distinctly different migration times through Long Point on Lake Erie, rather, in Ontario. So we'll compare that to the migration timing at Beaverhill. David's graph is at the bottom there, and you can see a crude graph of adults versus young versus season starting at August 1st. And you can see there's a lot of overlap. There's more young than adults, but not an obvious difference in their timing. However, one can more rigorously analyze that. So we did a 10-year comparison. Unfortunately, this never got published. With Beaverhill on the left-hand graph, you can see the adults in blue. At Last Mountain Lake, there's a much more distinct separation in their timing. And then at Delta Marsh, it becomes more different in more recent years. But this ended in 2020. So we never did get around to publishing this, but Myrthe has taken this and updated it. So here's the data from BBO showing a 7-day difference between adults and juveniles in their average departure dates, the average timing of the migration at Beaverhill. You remember at Long Point, it was 30 days. And what I tried to show in that previous graph is the separation at Last Mountain Lake in Saskatchewan and Delta Marsh in Manitoba gets progressively longer. So the adults leave first in a hurry, but the juveniles are migrating much slower. What we were able to do using the wing length and tail length of flycatchers, separate out only 15% of our sample. Could we do a best estimate of sex? But that shows that the after-hatcher females go first. That's the left-hand bar. Then after-hatcher males on average 5 days later, but lots of overlap. Then the hatcher males and then the hatcher females with a separation of 14 days between the after-hatcher and hatcher females. So more separation by age and sex than what is being shown. And it would be interesting to repeat this at Long Point and other bird observatories in between to get a trend. The question then is, why is the trend greater at Long Point, or the difference than it is at Beaverhill? The reason for the differential migration is, the argument is, the adults molt on their wintering ground. So they're in a rush to get south, get to their wintering grounds, grab the best habitats, and start their molt. But I suggest that an alternate hypothesis, not different than the adults, sorry, that's not the right word, is that the young need more time to put on weight, get in shape, learn how to forage. So a comparison of weights over time through the different bird banding stations would also be valuable to see if, in fact, the hatch years are not in condition to migrate quickly when in August, September, when they're starting to migrate. So this shows the trend over time that Myrthe was able to show that the migration timing is now earlier. So if you focus on the left-hand graph, the adult, the middle line, in 1990, the average Julian date of departure was around Julian date 220, and now in 2022, it's moved forward quite a few days, and Zoom has blocked the numbers, so you'll have to read the numbers to me, but I didn't memorize the difference there, but it's about 10 or 12 day difference. It's rather annoying that Zoom won't get rid of the top bar for me. Anyway, you can see that there's a significant advance of the migration of adults. There's a slight difference in hatch years, but not as much. Sorry, it was not significant. And then overall, when you add the two together, there's still a slightly significant change in increase of the average departure dates. So again, it would be interesting to compare this to some of the other long-term bird observatories east of us to see whether this trend is the same at all bird observatories. This is obviously a response to climate change, to warmer falls. It's possibly a response, but we can't show this to earlier arrival of the flycatchers, earlier nesting, and therefore the adults are able to leave earlier and head off for that molt that I've mentioned. But we don't have data on the nesting time, although MAPS data, the IBP data may help with that. And we haven't analyzed the spring arrival timing to see if in fact they're arriving earlier. So this earlier departure in fall could be a carryover from earlier arrival in the spring and earlier nesting, but that's to be analyzed yet. So thank you for that part. There's more to come, so you don't hang up. If you go to our bird bites, we have a terrific bird bite clip on this study that was done for us by Shane Abernethy. So if you do look up YouTube Beaverhill Bird Observatory, you should be able to find us. So Shane worked for us for a couple of years and did some data analysis looking at changes in morphology. So again, an issue surrounding climate change. And what he found is that the least flycatcher wing cords are 1 millimeter longer, which doesn't sound like much, but with a large sample size, it is in fact significant over the 30 years since 1991. So why would least flycatchers have a longer wing? Well, with warmer air on average, with climate change, birds need to decrease their wing load. I don't know why that just changed. Decrease their wing loading. And so they can do that two ways. One is they can grow slightly longer wings so that they can get the same lift in lighter air, warmer air, and or they can decrease their weight. So they have a significant decrease in weight over that same time period. And then I can't explain, but their tail lengths have also decreased over the 30 years. So I'm not quite sure why tail length would decline. I can explain, or I can rationalize the longer wings, but not the, suddenly my computer's turned on a timer. So, okay. So anyway, this is consistent with climate change. The migration is later now than 1991. Wing length is longer and mass and tail are lighter, shorter. So it's just a good example of the benefits of long-term data sets. There are many banding stations I know in Canada and elsewhere that have data sets like this. They just need hardworking students and or researchers to analyze them, and we're just barely dipping into ours. So the other thing that many of you know, and as Jonathan just pointed out, all the kinds of data that bird banding stations collect that all could be analyzed over time. So it's nice and spring in the top picture. I don't have a picture of a least flycatcher in the snow, so I had to take a solid owl one. What happens in the winter? Well, the least flycatchers migrate, and we have a very cool story to tell here. We've had 2 band recoveries of least flycatchers from Beaverhill to, oops. No, I'm really fighting my computer. Okay. And they nicely define the presumed arrival time in Guatemala. So the first band recovery was on October 9th. And then some years later, the second band recovery was April 15th. So this likely comes close to defining the arrival and departure dates of least flycatchers. Both of them were banned, well, they were banded in late summer, July and August. And then a couple of years after that, we trapped a least flycatcher that had been banded in Veracruz, and we actually caught it 2 years in a row. So it was obviously a breeding bird at Beaverhill, and it was trapped in Veracruz in May. So again, even with 3 band recoveries, we've defined the arrival in the winter, the departure in the spring, and the migration time headed north and a route up the Gulf Coast and not going through Jonathan's Island off the Yucatan there. So it's amazing how 3 band recoveries can be so valuable. So that when the first band recovery happened, we corresponded with a Peace Corps volunteer, and he invited us to come down there. So in early 1993 and 1994, BBO teamed up with Fundaco, the local national conservation organization, and Chandler Robbins and Barbara Dowell with the U.S. Fish and Wildlife Service. In 1994, interestingly, President Reagan and the Republican government in the US decided that volunteers should not be used to collect data that is being used by the American government. Of course, being Canadians, we were perfectly positioned to help out. So we mounted 2-week trips, a month of help to Chandler, so he didn't lose a year's data. So he had teams there in 93 and 95, and we were able to fill in 94. And we banded for that month on Cerro San Hill. It's a mountain on the east side of Guatemala that Fundaco was trying to get conserved. And we were very pleased to hear in 1996 that the nature reserve was formed. It's quite a large one. And there it is, 400 square kilometers, so 20 by 20 kilometers. So that was really cool that the 1 band recovery allowed us to travel there and help Fundaco and Chandler Robbins to get data to show how important this mountain peak was. It's interesting to take a little side note about Fundaco. So I learned an important message when we did this trip. Fundaco had about 30 or so people working for them, and none of them were biologists. None of them were doing ecological surveys. And it's like, say what? I can't find, I don't know of a Canadian organization that isn't involved with biologists and whatever their bird banding, bird studies, bird counting, whatever. So Fundaco's strategy was to have experts to work with the local landowners around this mountain to make the landowners 3 times more efficient on the land that they'd already cleared, so they would have less incentive to go up the mountain and clear more. So we had agronomists, foresters, even home economists. They bought solar stoves to make so that folks could cook food without chopping down the forest. A whole pile of things that were forward-thinking conservation initiatives without actually having the hard data to say why this mountain was important. So obviously Chandler Robbins' effort proved that, but they were already doing these other conservation programs before. So I recently looked at their website, and you can read for yourself here. It's a very well organized website. They're still doing all kinds of cool things, struggling for biodiversity conservation and sustainable development. And really, that's the key part to what they're doing, is sustainable development of local communities. And they have cool, my computer's fighting me again. Cool programs. 2 of those are eco villages, what I've just talked about, finding ways to make families more sustainable on the land, to give them agroforestry systems with products. They have a whole program looking at the health of women and girls and how to empower them to move forward. And I learned a lesson a long time ago. The best way to create conservation initiatives is to educate women. Sorry, guys, but women rock, and we've made a mess sometimes. So at BBO, we don't quite do that. We're still keen on banding birds, but we have a total focus on introducing people to nature. All of our banding programs are open to the public. We've in fact had the public respond by buying tickets to attend our events. So we typically sell 20 tickets per morning and 20 tickets in the evenings for owl banding at $25 a ticket. You can do the math, that's $500 a turn. And it sells out. The public are keen to come and learn. They arrive excited about learning. It's not just, what do we do today? We have nothing to do, so go out to the bird observatory. They've invested money into doing that, and that helps to fund the bird observatory. So our current budget is something like $300,000. By having a life membership, this is another thing to consider. We had 35 members in 2015. We've now got 1,400 members. Membership is $10 for a life membership. So when we send out a newsletter with information about what we're doing, what we plan to do, and ask for donations, we get a very healthy response from our members, way more than we would if we only had 35 members. It also looks good when we're applying for grants to organizations that were supported by 1,400 members, as well as getting large private donations to help sustain us. So thank you for your interest, and I don't know if I went over time, but I tried to talk fast. Thank you, Danny.
You made up time. It was great. Computer fighting and on all. So
thanks.
So does anyone have any questions for Geoff?
Or Jonathan?
Or Jonathan. I figured I would do you and then go back to Jonathan.
Okay,
but I'm happy to
go
back. Nope, it's all good to go back and forth. Go ahead.
Geoff, it's Rinchin here. How are you?
Good, thanks. Hi, Rinchin.
I wonder whether the catch your young least flycatchers are, because they're raised in what seems to be a sink area, maybe their mass is greater than maybe the long point ones, and maybe the long point ones have traveled a little bit and don't have as many insects to thrive on. So I wonder whether one could look at the mass of yours versus the LPBO ones. I don't know. It's just a thought that came up.
No, certainly I'd like to do that, to compare the mass of the adults and the young and over time. So we're finding the both sexes or both ages now are lighter than they were 30 years ago. Has that happened at Long Point and stations in between? One thing to remember is they don't breed at Long Point. So they're purely migrants there. They're not resident, whereas they're resident. So we get a mixture of migrants and residents, and obviously we don't know who's who unless we have to catch them at our map stations during June and July.
Yeah, that's right. That's sort of my point. You may be even farther, a little bit farther north. If you've got lots of aspen farther north, it's the same thing. It's going to be, your area is likely a serious source of good breeding habitat.
Yeah, for sure. And that was certainly the point of the first paper that Myrthe produced for us, that it's obviously a very good area for least flycatchers in the breeding season.
So with your lake that's disappearing, has your water table changed? Like, are you seeing the trees being water stressed and things like that?
No, it's sort of a bit of the reverse. So the water table is not far below, so we're not allowed to dig an outhouse anymore. But when we dug a 6-foot deep outhouse, the area sand, we started hitting water. So the trees are able to send down a taproot and still get lots of water. Starting in the 2010s and especially 2016, the lake started filling up again. So in the early 2000s, we had a regional drought, very little runoff. And then another factor, there's a lot of things that get mixed into this. The amount of runoff is actually determined by the fall rains. So in the fall, if it rains, then that freezes. The ground is now like a skating rink. When snow melts, you get runoff into the streams that fills up the lake. If the fall is dry, then the ground, it freezes like a sponge. And when the snow melts, the water goes into the ground to replenish groundwater and soil water, but you don't get runoff. So, and then the other factor controlling the lake level or affecting it are summer storms. So we had a storm in July 2016 that caused flooding in Edmonton. Highways were flooded, all the things you see on TV. And that storm stalled just south of the lake and through the main creek that feeds Sazamas Creek through August and even into September, ran like a whitewater river, filling up the lake.
Wow.
And then we've had a few wet falls that has resulted in spring runoff. But last fall was very dry. We've had very little snow this year, so I suspect the lake level will go down. But the water tables, so because the water table went down, that allows the aspen to move in and force out the willows, and the willows to move north into what were wet grasslands, were then dry grasslands, and the willows take over there. So it's an interesting seesaw battle. And it's cool that we've been there to witness it over the last 40 years. So it's a long answer, but the other good news, when the lake starts to retreat, like it's likely to do this spring, that leaves mud flats, and that's great for shorebirds. So when the water was refilling in 2016, 17, 18, 19, it was very poor shorebird habitat because the water was flooding emergent vegetation and dry grasses, cattails, etc. But last year was excellent for shorebirds with a dry fall. And so it'll be interesting to see what happens this year. So there's a whole seesaw battle happening around us.
Amazing. Does anyone else have any questions?
I have the question for Jonathan, if he's still there.
He's still here.
Do you catch least flycatchers, Jonathan?
Yes, acá estoy.
Do you know roughly how many over? Are they very common?
¿Cómo? Perdón, otra vez. Repeat, please.
¿Cuánto least flycatchers have you caught? My Spanish isn't very good.
Ok. No problem. The last flycatcher, sí capturamos aproximadamente en agosto a septiembre, pero sí tenemos, desafortunadamente, cuando llegan los flycatcher, nosotros bajamos de la isla, pero tenemos capturas de 10 a 15 individuos. Y tienes razón en el proceso de migración. Llegan primero los jóvenes y ya después se solapan, se juntan con los adultos, pero tenemos muy pocas capturas. Si tuviéramos el financiamiento para poder extender un poco más el monitoreo, créeme que tendríamos datos de muchas aves, de flycatcher, de warblers, un sinfín.
Great, thank you. It'll be interesting to know what you've caught in a few years. The other question I had is, in your pictures, you had diagrams of monarch butterflies. Do you get a monarch butterfly migration there?
Que claro, cuenta con ello. Si llegamos a capturar un flycatcher, te envío la foto y si está marcado, también te lo envío. La mariposa monarca. Sí, olvidé esa parte porque en Contoy hay un momento en que la migración de la mariposa monarca se junta con las aves. Entonces, en agosto hay migración de mariposa monarca y se ven revoloteando en toda la isla.
Cool, great, thank you.
So thank you very much for everybody coming. Thanks, Geoff. Thanks, Jonathan, for your wonderful talks. They were great.